Hello everyone, welcome back to PMAT1100. So as I already said last time, in this video we're gonna start the last module of the course, and we won't start with section 4.1, but we will be starting with section 4.2. In this section, we kinda do overview of what geometry look like. We're gonna go through a very basic theorem. Actually, some of you already learned in high school the Pythagorean theorem. Then we're talking about how to find distance given two points. Okay, if they give you the coordinate of 2 points, then we can use the distance formula to find the distance between the 2 points. Okay, so let's get started. Section 4.2. Oops. Alright, and we're gonna do Pythagorean theorem. And distance formula. This is a very easy one. Don't worry. All the math concept we do in this course is too easy. It is like for the beginner. So I mean, I'm sure that some of you already seen this in high school. So we kind of, it's nothing but it's a review of what we already learned. Okay, so on the first part, we're gonna do Pythagorean theorem. What is Pythagorean theorem? This theorem is invented by a Greek mathematician. Okay, Pythagorean. Okay, and he invented a pretty long time ago. I believe it's like 2,000 years ago, maybe more than that. And the theorem states that if you have a right triangle, okay, if you have a right triangle like this, and I call this the side over here is A, over here B, and this is C, and this is 90 degrees because this is a right triangle. Then the theorem states that if you sum the square of each side, I mean the leg of the right triangle, a square plus b square, then it will give you the hypotenuse, so that equals c square. A square plus b square equals c square. Everybody knows this. C is hypotenuse, A is the shorter leg, okay, B is long leg, okay, and C is hypotenuse. Okay. There's a proof on internet, but we don't have to go through in this course. The proofs tell us how they can come up with this formula, but we don't have to worry about much about the proof. So this is the shorter leg. Sometimes we call it the side, the short side, the long side. Okay. And remember that this theorem only works for right triangle, okay? Only work for right triangle. So if you have any other angle that is not 90 degrees here, then you cannot apply this formula. Alright. Let's jump to the example right away. Let me start with the easy one first, okay? Let's start with the easy one first. Example I'm going to use different color. Example 1. So in this example, I give you a right triangle. Okay, a right triangle. Okay, it's not a right triangle. It's not perfect one. We try to be perfect. Okay, so this triangle ABC. Okay, and I say that the length AB has the distance is 3, and over here is 4. So I want to find the length BC. So we're gonna apply right triangle, and we know the BC is hypotenuse. So because hypotenuse is the longest side, so I'm gonna put over here only work for right triangle. And another information you need to pay notice is let's use this color, is the hypotenuse is always the largest side. Okay. So if they draw a triangle, and you look at the triangle they draw, and you see that they have a 90-degree symbol. Okay. Then the opposite side of the 90-degree, this opposite to this 90-degree must be the hypotenuse. Okay, it must be the hypotenuse. So over here, BC is the hypotenuse. Okay, so I can apply the Pythagorean theorem. So I can find BC squared is going to be equal to shorter leg, which is A, is going to be 3 squared plus 4 squared, right? So it would be 9 plus 16, it would be 25. Then BC, you're going to take square root to give you square root of 25, which is give you 5, right? Give you 5. Okay. Some student ask me why not -5. Well, look at that. We have the measure of the side, then it cannot be negative because it's the measure. Okay. Over here, I did not include any unit because originally the question in my question there's no unit. But what if I put 3 centimeter, 4 centimeter? Then over here you have to put unit. All right. All right. Let's do another example. Okay. Example 2. In this example, you kind of learn a new terminology. Believe me, I want to be honest with you. This is the first time I've seen this kind of terminology. Also, not just you, but it's kind of very interesting though. It's good to know the new things, right? All right. The question is, what is the change? What is the change in elevation over 1 mile horizontal stretch, over 1 mile horizontal stretch for a road, okay, with 8% grade. Right here, the new terminology is right here, with 8% grade. I read it that, and sometimes, what does it mean by 8%? We need to figure out what does it mean. Okay, we need to figure out that. All right. So that's what the question is. Okay, and they give you the picture like this. Let me see. Okay, so they give you the picture of the elevation like this. Okay, so this is the elevation. So this is the right triangle right here, and they say that one of the this is the longer leg is 5,280 feet. Okay. Alright. And what is the change in elevation? What is the change in elevation? So elevation is like how high it goes in up, right? So basically they asking you for this. What is the change in elevation? Because this is horizontal. Okay, this is horizontal. It's a horizontal line. So this over here is horizontal line right here. The longer leg is it kind of a line on the horizontal line. Okay, so they ask you what is the change in elevation. It means how much it's go up. That's what it means. Okay, and they say that over 1 miles horizontal stretch. Okay, over 1 miles horizontal stretch for a row with 8% grade. Let me erase it and rewrite it. 8% grade. I was like, what does it mean by 8% grade? I mean, I look at that, I was like, oh, wow, I never seen this before. Okay, 8% grade. I'm gonna just mark this. Believe me, this is my first time seeing this too. I never seen this kind of terminology in high level math. Alright, so in order to do this, okay, so solution. I'm going to use another color solution. Alright, so how we find this? 8% grade. 8% grade. This is a percentage, right? So in order to find the elevation, okay, how high it's going up, respect to the horizontal line, then you change this to decimal number, okay, and you just need to multiply. So 80% grade is basically it tell you like it's like the slope, you know, okay. It tell you how many percent is going up. That's what it means. So in order to find the elevation, okay, so change in elevation will be equal to 8% will be 0.08. You multiply by the distance, the horizontal distance right here will be 5,250. Then it will give you 108 times 5,280. I'm sorry, 280, not 250. So give you because it's I'm gonna add a bit because it's 5,250 is a mile, because that's why 1 mile is 5,280. Okay, so I multiply that, and let me see, multiply 5,280, which is give you 422.4 feet. Okay. So over here will be 422.4 feet. I mean, you can keep it 1 feet over here. You multiply by 1, so give you 0.08 feet. I mean, it's the same thing, but it's good if you change it to feet. It's going to give you a nice number. But if you keep it a mile, so this is 1 mile, you multiply by 0.008, so it'll give you 0.008 mile over here. It's still the same. Okay, still the same. But in this case, I changed it. I changed 1 mile is equal to 5,280 feet. Okay. All right. So try to remember this. So this is a new terminology here. 8% grade. Okay. You just multiply by the horizontal distance, then it give you how high it goes. Okay. All right. There's so many to say there are so many word application using Pythagorean theorem. I can show you a list of problem I already prepared right here. Hopefully we can work together. Okay, let's see. Alright, USB drive. Okay, so I have right over here. There you go. So I have 3 problems. The good thing about this is that they give you the pictures, easier for you to visualize. Okay, but you have to be careful because on the test probably I cannot give you the picture because the insert math equation, I cannot draw a picture over there. It means that I'm gonna just give you the word problem. You have to draw the picture by yourself. Okay. Alright, so how are we gonna do this? How we do this problem? Okay. Let's do the first one first. Let's do the first one. I think I'm going to use the blue here. Alright. So a shed with a pan roof need to have some new roof beam fitted. The width of the shed is 5 meters. So this is the width 5 meters. Okay. The height of the roof is elevation. Okay. This is elevation right here to give you the height, how high it goes up, right? So we can call it elevation right here. Okay, and work out the length of the roof beam. So basically they're asking you for the roof beam right here. So you see that the shape right here must be the right triangle, right? Must be the right triangle. Then this is longer leg, this shorter leg. This is the roof beam. They asking you 1 dp. dp is what? Work out the length of the roof beam needed to dp. What is dp? It's kind of interesting unit right here. It's probably the C. Well, I don't know. They probably a mistake right here because if it is the decimeter, they should put dm, but dp probably there's a typo right here. dp. dp. Oh wow. That's dp. I don't know what dp is. Interesting. Okay. Let me think a little bit. Okay. So dp. I think there's a typo right here, so there's a mistake because I look it up. I don't see any unit with dp, and they say that it's the density decipixel. It's nothing to do with what we're doing. So I think that's a mistake right here. So I'm gonna just go ahead and probably they want to change to decimeter. Okay, so I'm gonna change it. I'm gonna give you this unit on a test, so don't worry. Okay, so I'm gonna change it. This is really dumb. Okay, so let's see. I can delete it. Okay, probably they asking you in decimeter. Okay, because it's meter and you want to change to decimeter. Okay, make more sense that way. All right. So this is the roof beam, the length they're asking you to find. So this is the hypotenuse. So we can find the roof beam is c squared equal to 5 square plus 1.3 square, right? And you put into calculator will be 25 plus 1.3. 1.3 square is 1.3 square is 1.69. Okay, 1.69. Let me see. I can make this picture bigger. let's see. There you go, bigger a little bit. Okay, so this is 1% in I plus 25. So I'll give you 26. So I'll give you something not right yet. So hold on. I need to get out of it. Okay, so they give you 26 point 69, which is you take square root, which is give you 5.66 meter. Okay, now we're going to change to decimeter. Okay, so you remember the unit column I already given you last time. So C actually will be equal meter to decimeter, so give you 51.66 decimeter. Okay, so that's how you do. Alright, question 2. Okay, his GPS he's 40 away, so he's standing right here and 40 away from the treasure, and he walked 24 meter due west. So due west right here, this is west, so it's due west here. Okay, how far due south? So this due south right here. So basically, they asking you the longer leg. Okay, they give you the hypotenuse. They give you the shorter leg. So they asking you for the longer leg. So c squared equal to b squared plus a squared, right? So the longer leg is b squared equal to c squared minus a squared, right? So which is 40 squared minus over here 24 squared. Okay. So 40 square minus 24 square give you 1024. Then you take square root. Okay, 1024. Then it give you 32. So 32 meter. Don't forget the unit. All right. Okay, so this problem, it kind of we try to find a leg. We did not find the hypotenuse. This one asks you to find the hypotenuse. Okay, for question number 3, go ahead and do it yourself. Okay, as the practice, go ahead and do it yourself. Okay, so I think I'm gonna start the first part of our video. On the second part, so this is for your practice. Okay, go ahead and do it yourself. On the second part, I want to, or maybe I'm gonna give you another one, because this is example 3. Maybe I'm gonna give you another example. Okay, all right, example 4. Okay, all right, so we're gonna do example 4 right here. So, and this example 4, so this is example 4, I'm going to put it right here. Let's see. I don't know whether I can. So I'm using red. Yeah, I don't know if I can write it on this or not. Let me try it. Okay, or maybe I have to use this. Yeah, maybe I have to use this. That's okay. I'm going to use this. I'm going to use, how about I'm going to use red one to do. Okay, so in this example, so this is example 4, okay. There you go. So in this example, they give you a picture, okay. Okay, this is called, this picture right here we call a contour map. Okay, the contour map, it help you see, okay, it tell you how high the terrain is. Okay, how high the mountain is. So it look like you see that the right over here, from here it starts from 1,000, right? Then it go up. The number is bigger, 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 bigger until the top right here. So this look like the top of a mount. Okay, I don't know what the name of the mount, so maybe they give you the name over here. Uh, uh, Okay, so you see that it's contour map, which is give you the height of the Mount St. Helens in Washington. Okay, okay. Just imagine this contour map is like the top view. So this is like the top view uh, of a mount. Okay, of a mount. Okay, okay. So the question is, on the first question, let me see. Let me read the first question down here. The first question, they want you to estimate the elevation of point A. So we look at the point A. Okay. So where's point A? Where's point A? Point A right here. Okay, point A right here. So we estimate the elevation. You mean they estimate how high point A is. Okay. Okay. We estimate how high it is. So how are we gonna do that? Okay. If you see this curve right here, this is contour curve. Okay, and it say what? It say that the point A right here is kind of above, on the right hand side is above 1500 curve, right? And I'm sure this is in a meter, so everything is in meter. Okay, this unit is in meter. Okay, so point A is above, so it's closer to the top, right? So it must be higher, it must be bigger number than 1500. So I'm gonna guess, because this is 17, so between these two curves right here, 1500 and 1750, and point A is between them. So I can say that estimate elevation of point A will be about 1600 maybe. Okay, 1600 meter. Okay, so which is just estimation. Okay, okay, just estimation. Just estimation. Okay. All right. For point B, if point X if point X and point Y are 5,100 meter apart, look straight down at the map. Okay, look straight down at the map. So this is important. This is very important information right here. Okay, so this is because this is the top view. So you look straight down. Is point X and Y at 5,100 meter apart. Okay, 5 degrees. Look at that, 5 degrees. You see that term before, right? The grade, the percentage. You mean finding the grade? You mean finding percentage right here, right? Of the trail that connect these 2 points. Okay, okay. It means finding the change in elevation first. Okay, finding the grade, it means finding the change in elevation. Remember, we did that in the first example. In the second example, no, in the third one. In the third example, no, in the second one. Yes. All right. This is point X and point Y. So this is the top view, and they say that if you look on the top view now, then the distance between them is 5,000 meter apart. But now it's very hard to see if you look at the top view like that. Now I'm gonna draw the side view. So I'm gonna put over here, because point X is 1500, and over here around more than 2,200, because it's point it's right on the curve. So it's point Y over here is 2,250, so it's higher. So point Y is must be over here, and point X is over here, right? And I'm gonna connect point X and point. And now this I redraw the picture, but with the side view. Okay, now we're gonna look down. Okay, and we see that. Okay, look down. I look down. Okay, I have a. I look down. I draw the eye like this. Okay. Okay, I look down and they say that x and y is 1500 meter apart. So this is 1500 meter apart. Okay, that's 1500 meter apart. Okay, okay, and so they ask. So now, right now, they're asking you for what? They're asking you for the grade. Okay, they're asking you for. In order to find the grade, you need to find the percentage, because it's the greater percentage. So I'm gonna draw the right triangle because this is for 1500. So over here is also 1500. Okay, so in order to find the grade, right, which is the percent, you need to find how high the elevation. You need to find how high the base. Okay, so how we're gonna find this? Very easy. So the height right here between this top and this top, and this top. So we just need to do the subtraction, because this is higher. The point y is higher. It will be 2250 meter minus 1500, right? All right, you put it into calculator. So what do you get? What's my calculator? Okay, so you get around 750 meters, so as the elevation. Okay, but in order to find the grade, we need to find the percentage. So the grade will be equal to the elevation. You divide by what? Divide by the longer leg. So divide by the distance between point x and point y when you're looking downward from the top. So divide by 51001, which is give you a decimal number. 750 divided by 100, so give you 0.147. So this is around 14.7%, because they're asking you for the grade, so you have to calculate it in percentage. Okay. Okay. Now on path 3, how far would you walk along the trail from point X to point Y? How far you walk along the trail from point X to point Y? It means that you walk this, which is I mean, in reality you cannot work like that, right? But they're just asking you. So how far if you walk along from point X to point Y? So basically they're asking you for the hypotenuse here. So which is very easy. So part C. So this is part B. Okay. So you just need to so I'm going to put xy. It's going to be, you apply the Pythagorean theorem. So it's going to be square root of what? Square root of 750 square, right? Plus yes, 5100 square, right? It gives you a very big number, and when you take square root, it gives you 5154.9 meters. There you go. So that will be the distance between the point X and point Y. I mean, which just doesn't make sense in reality, because I mean, how come you can just walk straight up like this? You climb up the mountain, you cannot just climb along the straight line like this, right? No way, right? Because the mountain is gonna kind of going up and going down like this. Especially if you look at over here, you see between this and this is 2250 and it's 2000. So this is a very ideal question. Okay, it's just used just for you to apply the Pythagorean theorem here. Okay, good. So that is the example, the last example for the first part of our of our lecture. So on the second part, okay, I want to talk about distance formula. Okay. Okay, the distance formula, it helps you to find the distance between 2 points, but you must know the coordinate of 2 points. So in order to get a formula, you must have the coordinate of 2 points. Let's say the coordinate of point A is x1, y1, and the coordinate of point B is x2, y2. Okay, and now you want to find the distance between A and B. So I'm going to put distance between A and B. I'm going to put it AB. Okay, DAB or just AB, same thing. So the formula will be, alright, x2 minus x1 square. Okay, x2 minus x1 square plus what? Plus y2 minus y1 square. Okay, so this formula only works if you know the coordinate of the point you want to find distance for. Okay, if you don't know the coordinate, then it doesn't work. Okay, then it doesn't work. Alright, I'm running out of page, so let's jump to the next page. Alright, so that is distance formula. Okay, so now let's do the example. Let's see I can put up the example or not. Let's see. So let's see. There you go. So I had a picture like this. Okay, I had a picture like this. This is a triangle, and you see that the coordinate of 3 points given. Okay. So the first question I want you to find is that I want you to find the perimeter, okay, of triangle ABC. Okay. All right. So let's find the perimeter of triangle ABC. Okay. So perimeter is just the surrounding length, right? So basically you need to find length AB, you need to find length BC, you need to find length AC, then you just add them up, right? Then they give you the perimeter. So I'm gonna find length AB first. Very easy, just apply the coordinate. Just apply the formula. So AB, so this is x2 right here, x1 right here, so will be x2 minus x1. Oh, let me check the formula one more time, make sure I wrote it down right. Okay, that's good. Okay, so we x2 minus 1 will be 1 minus 1 square, right? x2 minus x1 square plus y2 minus 1 will be 4 minus 1 square. So we just give you what? Give you it will be square root of it's going to give you 4, right? And give you 4 square plus 3 square, right? So let me erase a little bit. Okay, which is give you what? Which is give you the 16, right? 16 plus 9 is 25, right? So square root of 25 is 5. So that is distance AB. Now we're going to do the same for BC. Okay, the same thing. Okay, same thing. So 4, 1. So this is not a nice one. So square root of 5 AC. 3 minus 1, 3 minus 1 square. 3 minus 1 square. So which is give you 16, right? Plus 4, which is square root of 20. Alright, then perimeter will be what? Perimeter will be equal to AB plus BC plus AC. Then you just add them up. Just 5 plus square root of 5 plus square root of 20. And you don't need to change to decimal number, okay? Just leave it like this, I understand. So that is perimeter of triangle ABC. Let's see, I can come up with something. Okay, the question B is, oops. Question B will be, is triangle ABC a right triangle? Okay. A right triangle at B. It means that I'm asking you if this B is 90 degrees or not. Alright. So remember that in order to be a right triangle, it must satisfy. Okay. In order to be a right triangle, it must satisfy Pythagorean theorem. It over here, it means the sign. It is the sign. I mean this. The sign must satisfy Pythagorean theorem. Okay, so you look at the old sign right here. This is 5. AB is 5. Square root of 5. BC is square root of 5 is smaller than 5, right? So over here is 5. Over here is square root of 5, and over here is square root of 20. It look like that the square root of 20 is the biggest one. So if it is the right triangle, AC must be the hypotenuse. Okay, so we're gonna set up the Pythagorean theorem. Let's see if it satisfies Pythagorean theorem or not. Okay, so the Pythagorean theorem say that c square, right? So it will be square root of 20 square. We assume that this is hypotenuse. Okay, we don't know this is the right triangle yet, and we try to see if it is equal or not. We try to see if it equal to the longer leg square. It will be 5 square plus the shorter leg square, square root square. Okay, let's see the work or not. Alright, square root of 20 square is 20. Okay, and square root of 5 is 25. Square root of 5 square is 25. Square root of 5 square is 5, which is give you 20 and 30. So do you think this is equal? No. So this is not equal, and because this is not equal, so I can conclude that triangle ABC is not right triangle. Okay, it's not right triangle. Alright, because this does not satisfy the Pythagorean theorem. Okay. Okay. I think I'm gonna stop the lecture for section 4.2 with this example. On the test, I may give you another shape, and I'm asking you to find a perimeter. I may ask you to find area. I could ask you anything. Okay, and you might have to use the distance formula like this. I may ask you some category like this, either a right triangle, if it is a rectangle, or if this is the equilateral triangle, if this is a isosceles triangle, right? So everybody know what isosceles, right? Isosceles is if it you have two sides equal, then you have isosceles. If it you have three all sides equal, you have equilateral. So I'm going to give you a very add you some more important information. Maybe you might need this information on for the test. Okay, so I'm going to put some remark over here. Oh, I like purple color. It's beautiful right here. So if you have the isosceles triangle, then you have two sides equal. So for example, I have isosceles triangle at A, and this is triangle ABC. Okay, it means what? It means that AB equal to AC. Okay, so this is mean AB equal AC. Okay, and if it is equilateral triangle, okay, equilateral triangle look like this, right? Equilateral triangle ABC mean all the sides the same, all the sides congruent, all the sides congruent. It means AB equal to BC equal to AC. Okay, so this is kind of some extra information you may need it for the test, or maybe if the homework system give you isosceles or equilateral, you know what you have to do. Okay, so I'm gonna stop right over here, and I'll see you next time for the next lesson. Bye bye.